First, I'll displace by distance, say x. Then next again, I'll give further displacement of 2x. This is the elongation is 0 now, natural length. So from this mean position, so what I'm going to do is I'm going to give a displacement. So next further x agent what happen will give displacement of further displacement x. Then you'll give further displacement x here. What about the work done? What is the energy stored in the spring? All that one. So we know the energy stored in the spring, let it be U1 here, U2, U3. So what is the expression for the energy stored in the spring? So we know the spring force. What is the basic idea of a spring force? Spring force is given by F equal to Kx. Can you remember? Then work done by the spring, F into dx. Substitute this, Kx dx. What all work done by the spring will be stored as potential energy. So write 0 to x, Kx square by 2. Now what is this? Potential energy stored in the spring. Potential energy stored in the spring. So U equal to Kx square by 2. What is K? Spring constant. What is X? X is the, it can be deflection of the spring. It can be elongation or compression. You can take that as elongation or compression. And then what about the energy stored in all the cases? So first U1. So U1 with how much? Kx square by 2. What about U2? What is the total elongation? Will be 2x. This will be 2kx square. What is energy stored in the third state? The total elongation will become how much? 3x. This will be 3x whole square. Let me write in this way. 9kx square by 2. So this is the energy stored. From where, who will pull this block? An action agent. So let me bring that one. An action agent, W1. Next from, let me write W1 like this. Now action agent will pull W2. Again, the action agent will pull this W3. So what is the action agent? Myself. I'll hold one end of the block here. And I'm going to slowly pull that so that the spring gets elongated by X. Then what is work done by me? W1. Then again, I will further elongate by X. Then what is work done by me? W2. I'll further elongate by X. What is work done by me? Let it be W3. Now you look at this particular thing. Already the spring is having some elongation. I'll give further elongation X. I'll give further elongation X here. So this particular thing we can study by two means. One graphical or we can also take help of this one. So now who will pull? So initially there's no elongation. What is the initial energy in the spring? 0. I'll elongate by X. Then how much of spring got energy? U1. Now from where this energy in the spring will come? The action agent, so myself. So my muscle energy, what happened? The chemical energy stored in my muscle, what happened? Now is available as elastic potential. Further I do work to further produce elongation of X. So what is the total elongation? Now it will become 2X. Now how to calculate this W1, W2, W3? So what is W1? W1 should be equal to U1. So this should be equal to how much? Kx square by 2. What is W2? Already it was having U1. Then I did work and it has become U2. Is that okay? The difference of this energies is what? That W2, no? The difference of energy in this one is W2. So what is W2 should be equal to U2 minus U1. U2 is how much? 4kx square by 2 minus kx square by 2 will be 3kx square by 2. What is W3? U3 minus U2. So this will be 5k x square by 2. What is the ratio of energy stored in the springs? Will be 1:4:9. What about the work done? Work done will be 1:3:5. No. So why I just picked up this situation is to produce elongation of x, you have to do work. To produce the same elongation further elongation x, what you have to do more work. You can see 3kx square by 2. Again, to further elongate what you have to do more work. But the elongation is same. First event, elongation x, second event, elongation x, third event, elongation x. Total elongation is 2x here. Means when it will be easy to elongate, when spring was natural length to elongate by x, or it was having elongation 2x to make it 3x. So where I'll be doing more work, W3, in the third event, I should do more work. Because any reason for that? Because we have to do work against here, how much of spring force? K2x, no? 2kx. Here, what was 0? And as you start moving, spring force will be acting. So this is about the work done by X agent to produce the same consecutive elongations will increase. That's what I just mean to say. So let's go for some graph. Already we have come across graph. No, graphically, can we interpret this? What all we discussed, no? Can we interpret this everything graphically? So there's a curve. Along x-axis, I'm going to pick up the spring force. You write it F here, that one, and this is x. So this will be x, 2x, and this is 3x. And there's an initial small basic idea. Once you get this one, it'll be much easier, because any theoretical questions anyway, if they ask, you'll be in a better position to answer them. This is x and y axis. Okay, now let me shade this part of okay, now see this. What are that U1, what is W1, you can write it. What about the spring forces? This will be kx, this will be 2kx, this will be 3kx, no? Spring force. And what is this? This is the elongation. What is the x-axis? Elongation. What is W1? This is W1, no? O, A, B, C, D, E, F. What is W1? Area of this fx graph will be work done. Can you recollect? So W1, shall I write W1 equal to U1 equal to area of triangle OAB. What about U2? Area of trapezium OCD. Sorry, area of bigger triangle OCD. So what should be W2? W2 should be area of trapezium ACDB. Area of trapezium ACDB. Then what is U3? U3 again area of bigger triangle OEF. Then what is W3? W3 is area of trapezium CEFT. Next. Okay, this is about like this. No, if you want, you can take even the graph also. Through graph also you can work out. There are several ways to deal with the springs involved. Whenever spring comes, several methods are there. And now already, so the same thing, let me summarize. In the numericals, no, already it is elongated by x1. Then it is further elongated to x2. The same thing. What will be the work done by external agent? The difference in elastic potential or work done by the spring force, how you write? How the spring force will be acting? Spring force will act in this direction. So spring force does negative work. So what you should write? Kx dx x1 to x2. Here negative sign you put it. Why negative sign? Spring force will act opposite to displacement. So this should be k x square by 2 x1 x2. It does negative work. So if you don't want that sign, so just take it out, no problem. In the numericals, you should be careful about work done by the spring. So when spring force does negative work, when it elongates, when it does positive work, when it compresses. So able to get this. So again, you have to be very careful about the work done by the spring force. So what all you can take a graphical help, or what you can do, you can just take help of the integration. Moreover, the spring force is variable, no? So therefore, what happens whenever problems arise, you have to be very careful. Is there any elongation? Is there any initial compression? So from that what you have to manage the conditions. So initial what there is elongation. How much work done to further elongate? There's a work done. There's only better. Let me give magnitude. Because some of you are asking negative sign. In the numerical, take care about that sign. Spring force does positive or negative work. Okay, there's the overall basic idea of this one. So let's come for vertical springs. So if you take the so